have one that's like super thin.
Whoa. I don't think I like that.
I'm excited.
I feel like it would break.
Yeah.
Okay.
I don't think I'll be able to
That was like angrily strangle it. Like,
what weekend are going?
yeah,
Let's
Thursday.
X equal to 6 cosine t, y equal to 2 sine t. Okay. This is parametric.
Wait, isn't it cosine of a certain angle?
Yep.
But there's no angle.
T.
Oh, the angle is called T.
Yeah, you can call your angle.
And here I am in degrees, doesn't matter, degrees, I mean radians, I'm in radians, doesn't matter which one, but your one is going to be different. If you're in degrees, so I would suggest radians. And parametrics, and let's go what equals, xt, or x and y, 6 cosine t, oops, and 2 sine t. So here are things that you need to notice before you press enter, or graph, or window. What you're going to take a look at is you want to see how this ellipse is drawn, what each of the parts mean. Okay. So for instance, y cosine up here, y sine, y6, y2, and t we'll get to in a second. Okay, so window. What do you think the center might be? 0, 0. Okay. All right.
Do we not have to go back?
So it might be 0, 0. So let's go negative 10 to 10 on the x, negative 10 to 10 on the y. And now T min, T max. If we're in radians and I asked you to complete just one period, what would you give me? What interval would you give me? 0 to 2 pi. So let's try that. 0 to 2 pi. Okay. Steps of 0.1 is fine. Okay, you don't want it too big because otherwise it looks choppy. That's not going to look correct. So and you don't want it too small because then it's going to take forever. All right. So now let's go back to y equals. And you actually want to watch this being drawn. Okay, so highlight this part of it. And if you highlight, just keep pressing enter, you should see that bar with a dot on it. This will draw it and you'll actually see how it's being drawn. Okay? Alright, so again, there's things that you need to pay attention to is y cosine, y sine, y6, y2, and then t we'll get to in a second.
That's amazing.
So graph.
Watch it. It's amazing.
Oh, that is pretty cool. Yeah, mine's not going anywhere, buddy.
Is it really?
Yeah, mine's probably in degrees.
Yeah.
Thanks, physics.
Yeah.
There you go.
Okay, so what does this 6 give us?
A.
The side.
Major axis, right? The
Yes.
A value. Yeah, half of the major axis. Major axis is actually 12, so this is actually the A value. Right?
what?
2 then would be the B value. Now, why is it cosine here and sine here?
Cosine goes.
Oh, cosine goes for the X, sine goes for the Y. Okay. Oh, and how did this graph?
Backwards.
Counterclockwise, right? So this graph counterclockwise. Right, there's A, there's B, and this one graph counterclockwise. So if I were to draw this, if you just draw the ellipse like this doesn't give us any information on how it was drawn. This gives us information on what it looked like at the end. It's just a path. Okay, so think of this circle as an ant. The ant is traveling on a path. An ant, this is just the path that the ant takes. Okay, it's not unless unless you like Hansel and Gretel and leave little breadcrumbs, right? You're not going to see this ellipse, right? You're just going to see the path. So this one here, what you also need to know is where do you start. So always mark it, t equal to 0 is here. And we go counterclockwise, correct? And you can just put a few arrows on there. Okay? You always want to know where you started and then which direction. Okay? So then here's a question. I want you to come up with I want the same graph, the same path, but now I want it counterclockwise.
You
Wait, this is counter, counterclockwise. Starting at t equals negative. So now we want to go clockwise. Starting at t equal to 0. And keep cosine and sine the same and make it as easy as possible. Okay? Make it as easy as possible for me to remember because you know my brain just hurts right now. Okay? So you figure it out.
Yeah, you just do it. No, just kidding.
Because then it starts.
No,
If
it's
it
still,
goes
it's
negative,
still
then it's still
going
going
counterclockwise.
It's the same.
It just changes the starting.
Yeah.
You do it from
I still want it to start at t equal to 0.
Oh, you make one of them.
Do you go from 0 to
No, keep the same window.
negative?
I made it
it
was really
really
times. Yeah, then you said T, and then.
Make it easy for me to remember. That's not easy, because then I have to remember one of them has a negative. That's not negative. My brain hurts.
Don't you
I
just
only
switch
did 5 minutes in this class. My brain hurts.
switch the?
No, that makes it.
Yeah, the
not.
sideways in case of like.
Never mind.
Figure it out.
Wait, do you switch the A and B?
No, you make the.
Do you make the t negative?
I just changed that.
Wait,
Yeah, it does.
and you said not with
That
negative?
helps you come like more this way.
So we can both be negative? No, only one of them. can.
Just make the
No,
t
it goes to
negative.
Negative, because then that means I have to remember which is negative.
Oh, switch the cosine and the sine? No, she just said no. I'm so behind. You guys are like.
I don't know, maybe cosine it, I don't know.
Yeah, switch the cosine.
Wait,
You said no
just
too.
did.
Yeah, I did say no to that.
You did. You
I
said
did
keep the
say
sine and the cosine
Yeah.
the same, and keep the
Oh, I did
window.
say keep the sign.
Yeah.
Oh, you're right, because that's too
Wait,
much
can
for
we
me
just
to
make it a
remember.
make it negative t?
See, my tired old brain.
Oh, if they're both tired and young brain.
I wanted to go clockwise.
Can they both be negative?
Yeah, I wanted to go clockwise. I just made one of them negative.
Yeah,
Yeah,
that's
so
what
they
I was
say
saying.
negative t.
Negative T.
Oh,
Can we make both of them negative t?
Wait. Okay, so here's the issue.
I'm stressed out.
When I graphed it.
If you just tell me this, I gotta remember which one.
So make
Oh,
them both be
they
negative.
both.
Oh, mine worked.
Why is it so hard?
Oh, yeah.
Why couldn't you just tell us yet? Honestly, I'm not smart enough for this.
Because you can figure it out. Okay, so now if I make both of them negative t.
Well, look at that.
Well, look at
I think it's so cute. That should be our mascot for.
Lips.
A moving ellipse.
Mouse.
Put a hand there.
Okay, so this one's here.
No, not an ant, an aunt.
Yeah, she's scared of butterflies. Butterflies are scary.
Okay, so
Have
this
you
one's
seen
here.
SpongeBob?
Ladies. Sorry. So 6 cosine negative t and 2 sine negative t. Now, some of you said, oh, just make this one negative, right? You actually made this one negative up front, did you?
Yeah.
You did, okay, so the reason why that is actually accurate, you can do it that way, but this is an easier way to remember, right? Cosine t, wait, let's see, so sine negative t, this is odd, so therefore this is equal to negative sine t. This one's even, so this is equal to
Oh, yeah.
cosine
Oh my
t.
God.
So that's why this works, but this is easier to remember.
My mind is blown.
Why does that happen?
So this is easier to
Oh my
remember, even though that works, right?
But does it only work if you have cosine and sine as your, or like if you have like an even and an odd function as your
But we're doing ellipses, so we always have cosine and sine.
Oh,
All right, so now, what if we wanted to start at, I wanted to start down here.
Oh, then you just have to change.
Okay. And same window, but I want to start down there, use the same window. So how do you change your values? 6, -6, -2,
And you still want it to go clockwise? Oh, no, now it's going counterclockwise again.
This is going to counterclockwise.
are we keeping it as negative t or changing it back? Oh.
Yeah, so here, yeah. I'll get you started. Like that. There's actually a couple of correct answers.
Okay, so t is t equal to 0. It's just
Get it?
Don't you just subtract it by pi over 2, like t minus pi over 2? Or that makes
Or both. And yeah, remember, what you're gonna do to one, you wanna do to the other. You wanna keep it simple. Why? Because my brain hurts. I don't wanna do hard things. That's what your brain's for. Does that work?
or you could add pi. I tried everything pi between the start and the pi. For some reason.
Does that work?
No, I added pi over 2 and it started at
Oh, there it goes. Starting at the bottom, right?
Oh,
This is so crazy.
no, I for some reason I didn't think pi between the
Now
start.
it's-
Does that work?
Yeah, why?
No, because I put.
Okay, so now I said.
Wait, because I
So here you could also do
because I had the
plus 3 pi over 2.
Well, it's still
That
in the
puts it
gap.
at the
If you add. Plus 3 pi over 2, does that work? Oh, there it is. Nikki, you said something about a gap?
Yeah, like it doesn't close it off. Is
Oh,
that just because of
well-
if you increase your t? Yeah,
I could increase my t step to 0.01, but then it would take forever to grab it. Mhm. Yeah, well, if you want to make it a circle, what do you need to do? Yes, change your A into B. Okay, so now, how about if we want the center, if we want to change the center?
Outside, so mine's outside.
Okay, so here we want center at, let's say, 3 comma negative 1. What do I do? Oh, this one here, you can start here, and you can go, whoops, wait a minute. 3 comma negative 1, center. So start here. That way. Okay, do we get it? Oh. So this is 6 cosine t plus 3, and then y equal to 2 sine t minus 1. Does that work?
Then have to be.
There it goes. You can't actually see where the center is, but if you had a ruler, you could find it. Okay. All right. We good?
For mine, I had to start it at negative t to get it to go.
Negative t?
Yeah, I thought it was
This is
counterclockwise
weird.
normally.
I remember, yeah.
But for some reason. Here.
Negative here is what makes it go clockwise.
No, yeah, but it's going. My clockwise is so.
Look at your window.
It's my window is 0 to 2 pi.
Let me take a look at it. Okay, so then I have a question. Make the equation of the Ferris wheel. That is, it has a radius of 20 feet. Oh, there's one other thing I didn't do, but I think you might be able to figure it out. Well, maybe not.
Okay, we can't.
We're stupid.
So the radius of 20 feet, you are going to pick up passengers down below, right? So you're going to pick up passengers. And you want to go counterclockwise. And then I'll change it on you in a second once you get this, because this is kind of easy.
I was saying t equals 0 is at the bottom.
Yeah, you're picking up passengers down at the bottom. So that means you gotta pick up a passenger, t equals 0, you gotta pick up a passenger down at the bottom. Okay, did you get it? Yeah?
Yes.
Okay, Kristen, what'd you get?
20 cosine t minus pi over 2 and 20 sine t minus pi over 2.
It's gonna pick up passengers.
Gotta pick a passenger. Okay,
Well,
so
it'll
now
pick
I
up
gotta change it on you. There's one thing we forgot to do.
On the y, if you add 20, then like so it's 20
Oh, gotcha.
sine t minus pi over 2 plus.
Oh,
I didn't understand.
Oh, Mr. Cox, it depends on your
Say it
coordinate
again.
system.
Say it again,
I
Kristen.
went on
Talk to me. Oh, okay, so what we have now is this, right?
What was your coordinate
Yeah, it
system?
depends on your frame of reference.
Depends on what your point of reference is. Here's my point of reference.
That was not made clear.
Yeah.
It wasn't made clear, and that's okay.
So
Well,
try
it's not
So
okay.
you
Your
don't?
Ferris wheel's like half
Well, and you
Wait, I'm very maybe I just want a
Subway
partially
Ferris.
subterranean.
Okay, so now I want my Ferris wheel to be
in the sky.
up here, right?
So then.
Like that, right? So now I need to add 20. Add 20 to the y, okay. All right, so now we have this, correct? Right? One last thing. This is a 20, this 20-foot radius, right? I want, oh my gosh, this would be kind of a lot, but that's okay. This is one of the Ferris wheels I will not ride on, but that's okay. 20 feet. But, so here we start down here, we go around, right? So a complete circle would be 2 pi. So 1 revolution is 2 pi seconds, correct? I want 1 revolution in 12 seconds. How do you change your equations? And again, make it easy. I want 1 revolution in 12 seconds.
Like you won't get back to go back. So you want
T to be
Yeah, multiply t
bigger.
by 6 over pi. Yeah, should be.
Yeah.
I don't know. So here what I can do is, in my window, if I do 0 to 12, right, this is 20 cosine
Wait,
How did you do that? Oh, it's I got the plus. Because it's because I put my T max at 12, but it's still doing every like right in between like the positive and the negative. So you there's a button for that, right?
That's really
You know how hard my life is? Like, I retype like crazy.
So it's not even a real circle.
Let's go see the.
Squares up your.
There we go around,
So you can
and
set it-
around and around and around. Around and around and around she goes, and that was too many times.
Why didn't it show up like that? No. Stop it. Can you do +1?
I want 1.
Go.
No, it's doing it again.
Fiona, if you do second on, it'll stop it.
The one that's there. Not this.
So how?
Which one?
Yeah, you're trying to make it happen in less time, but
Oh my goodness. Oh my goodness.
Oh my goodness! Oh my goodness!
That's not very fun.
Oh my god!
like multiply.
Yeah. That's a
Is what's in green what we're doing?
I know, they're doing the same thing, aren't they? Yeah.
Oh, wait, those are-
This Thursday is
It's a pretzel. Whoa,
All
that's
right,
so
so
cool.
here,
This is just three.
This is
The
from
trick
Trig.
was so bad. No.
which letter are you gonna deal with on that one?
B.
Okay, sure, deal with B. So how are you gonna deal with B?
I don't know.
Do you remember from Trig, way back long ago, over 2 years ago? Yeah, I know, that's why I put this up,
Yeah.
see if you remember. Remember what the period was? It had to do with B.
The two
Oh,
over something.
2 pi over
Pi
b,
over
yeah.
B.
I knew there was a 2 in there.
That's right, you did. Okay, so 2 pi over B. So I want the period to be 12, that means B needs to be?
Pi over 6.
Pi over 6. So does that work? Let's see.
I did that.
6. Pi divided by 6. Does that work?
Wee, go slower.
Well, now remember, the window, make sure you go from 0 to 12, right?
Oh, look at that, it just stops. Wow.
Stop it. Okay, there it goes, one circle. That's pretty cool. Alright. Oh, so actually, JK, you really want to
JK.
You really wanted to go clockwise.
So you just make it negative.
Wait, why?
Oh, just make it negative, okay, so that's all right.
Well, technically, it's like counterclockwise.
I did.
Well,
Why?
we kind of messed up on our clockwise and counterclockwise.
So does this one work? There you go. So clockwise.
Why does it need to be clockwise?
That Ferris wheels always go clockwise.
Well,
No.
no.
Well, it depends on.
Depends on which way you
The
look
one
at
in
it.
Grammar
Grammar
preference.
Well, it depends if you're talking about like the people go like which way the people are facing or which way.
I don't know.
Yeah.
The one in downtown San Jose, if you look at it from the side, you get in line. It goes counterclockwise.
You go the other side.
Yeah, and then you stand on the other side, going clockwise.
See, depends on where.
Oh, I forgot.
Okay, so this one here, we're gonna change it so that 1 revolution is equal to 12 seconds. And we're gonna go clockwise, right? So x equal to 20 cosine negative pi over 6 minus pi over 2.
clockwise? Just clockwise?
Because I want to set this up.
Oh, wait. Just kidding.
Oops, minus. Okay? We do it like that?
Not really.
Oh, so now they're changing it to be negative.
Okay.
No. I get an error.
So now we want to take a passenger on the Ferris wheel. They're gonna go this way.
Like the buddies?
Bob is gonna.
no.
Wait, what?
Can you
I don't
hear me?
remember anything SpongeBob
I
related.
don't remember this. This is why I can do this problem again.
I remember the problem, and I don't really think I
I don't
can blank
remember
space
his
on that.
I remember this.
I drew a space when I
know, like,
drew the problem.
did we make a Ferris wheel?
I'll write your name.
No.
Blank space.
Thanks,
Stop
Kristen.
it.
No. Thanks, Kristen.
So SpongeBob throws the ball at, let's see, SpongeBob throws the ball at.
Patrick.
Huh?
Sandy. Mr. Krabs.
Squidward!
We're talking about velocity and angle, not the.
Oh, 60. Feet per second. Okay, go ahead, it's fine.
Are you sure?
SpongeBob is one word?
Of course it is.
Pi over 4, or pi pi over 3 towards the Ferris wheel. Oh, and you also need to know that SpongeBob is 75 feet to the left of the Ferris wheel.
He's
75 feet tall.
He's like 3 years old.
Maybe it's a giant sponge.
That's their whole life.
Now, when we are at Disneyland, I do not want you trying this. It's not you trying this.
Oh, they have cages.
What if we calculate?
Yeah, they have
it
cages.
all?
Yeah.
we should.
But you can
Yeah,
like
you
move,
might just
right?
get easily.
We can still throw it at it.
So on the Ferris wheel there, you have to be on one of the stationary cars. You can't be on one of the swinging cars.
Fun though.
Oh, those are fun.
Wait, why not?
And do we get extra credit to do this? By that time, we
I used to do
You
it.
really think it would matter by that point?
Go on the swing.
Okay, so this is how we went on SpongeBob.
And they're caged, so it's not like you're gonna fall off.
Unless the whole thing falls off.
So
SpongeBob's SquarePants is here.
see if it works.
Oh yes, make that.
Yes.
Okay.
Wait, why does it have an
I
extra
think
head?
So 75 feet from the
Okay,
center.
so
Center.
You're able to take
Mode
up
knows
all
that.
space
In my notebook.
There it is. There's SpongeBob, right?
And
So, and you're gonna be here. You're gonna get on
But it's like not, was never placed in my brain now.
equation for SpongeBob. Give me the equations for SpongeBob.
Wait, really?
Ball.
this?
For the ball. For the ball.
Oh.
He's throwing himself.
A to Z.
X equals
D
60 cosine T.
What is it?
No, 60 cosine pi over 3. Pi over 3
60
T.
cosine T.
60 cosine pi over 3 times T.
Oh.
Wait, what?
60 cosine pi over 3 times T. Y is? Yep, projectile. Because the ball is gonna go this way. You're gonna go this way, and you catch the ball.
And then y equals.
So y equals to?
Negative 16 T squared plus 60 sine
Sine pi over 3t
plus 0. Plus
plus,
L
Because
0.
isn't the initial.
I don't know, how tall is SpongeBob?
3 inches.
He's
He's a tiny
SpongeBob is 3 feet?
No, he's a sponge. He's like this big.
But he's not throwing a ball.
Well, when he comes out of the ball, he's like a dish sponge, and a dish
Okay,
sponge is
zero.
like layered
Okay.
with legs.
So there's
I
SpongeBob.
question.
It's
Alright, so Ferris wheel, now that I've positioned the Ferris wheel over here, what changes? Oh, center, so therefore this becomes 20 cosine.
T minus pi over 2. Plus 70.
Plus 75, okay, so then this one is 20 cosine negative pi over 16 minus pi over 2 plus 20.
Is it sine?
Oops, okay, so do we catch the, does he catch the, do we catch the ball?
And then what was it? At intersections.
Alright, so here, you gotta be a little careful on this, so 60 cosine pi over 3t. Negative 16 squared plus 60 sine pi over 3t. That's it, right? I have to change my center, don't I? I mean, my window. So X min 0, X max. 75 plus 20. 75 to make it even 100. Okay. There's my window. Oh, and the next thing that you need to change is go to mode. On your calculator, I don't know. But hold on your calculator, go to here to simultaneously, because then it'll graph simultaneously. That way you can see if SpongeBob gets it or not. Okay?
For X, and then 0 to 1.
Why are you not going clockwise? Thingy? Why does this
Oh, I
work
just
so
started.
Mine's just a line.
Is okay.
Yes. I guess that he really doesn't catch it. Okay, never mind. I know my mind.
Did you get what's on this by a
Oh, this is so much.
I did. It's
Wait, you catch any, guys?
No.
You catch it?
Not even close.
Not even close.
Wait, who is he trying to throw? Like what?
Sandy, I think.
No,
So like so like the person gets on at the bottom and then right as they start he throws it. So it's like,
You didn't have the 75.
So not even close, close but no cigar.
That's what
No, not even.
What is that from?
Okay, so what's the easy thing I can change?
Wow.
We can change,
Yeah, it was.
my dad says
okay, you have no control over the Ferris wheel.
Change the angle that he throws it out, or the
Okay, so you could go over
Wait, I
there.
thought it was
Ladies.
75 was left.
Ladies. So this one here, you have no control over the Ferris wheel, so you actually do want them to catch the person on the Ferris wheel. You want to be able to catch the ball, so SpongeBob has to control what he does. So what can he change?
Initial velocity.
There's two things,
Angle.
angle and
Velocity.
velocity. Okay, so which one should we change?
Angle.
No, they.
No, velocity is
Sure, velocity.
All right, doesn't matter, should we slow it down? Tell me what to slow it down to.
30.
Wait,
Cut it in half.
wait, buddies.
Cut it down to 30?
Oh,
Let's
yeah,
see.
that's
Does it work?
No.
No,
What about 40?
Okay, 50?
Yeah.
Is there a way to do this without just doing guess and check?
No.
No.
Oh,
Does it work?
maybe.
Oh no.
Just
yes.
No, does this?
Well, it depends how far you
It
can
just
reach, you know.
That's actually
I feel like
quite true.
that's a
Depends on how
safety
far you
hazard.
can reach. So,
But you're supposed to keep your arms and feet inside the vehicle at all times.
There's also not supposed to be projectiles aimed at you as you're.
so we should probably try
45.
47.
7? Sure.
43.
Earlier we did 47.
47.
Whoa.
Does that work?
No.
Maybe.
No.
Oh.
Wait, what did I do?
Are we trying to get it like average?
What if we do 49.3?
Or how about the 49?
How about
Yeah,
49 or 48?
Alright, let's try
You guys make your
49.
windows
I was just kidding.
Don't
I didn't
do
do anything.
anything.
I just saw the first number.
What's everyone's windows? Let's all share their windows.
0 to 100 and then 0 to 40.
Oh, I see.
Oh, yeah, 49 works pretty good.
Wow.
That's not right.
Yes.
Nothing is
I did that.
Okay, so where's the
49?
calculus?
What was it?
Nowhere.
That's what the section.
There is no calculus. Okay, so here we go. Here's the calculus. So we're gonna go with 49 on that. Okay, 49, because you can slow it down, you can certainly slow it down. So here we want to find what's the minimum distance. Okay? So minimum distance, so I need the distance between the ball and the Ferris wheel. So distance equation, square root of x, yeah, x2 minus x1 squared plus,
From physics?
No, that's
Why
why.
is
y2 minus y1 squared, and this is from Pythagorean theorem. Okay, so now what we do is square root of this squared, 49 cosine pi over 3 squared, t squared, right?
No,
This all squared is 49 cosine pi
Why
over
are
3
we
squared,
doing
t squared, correct?
Yeah, but how is that?
Isn't the minimum,
That's just for this one.
But you're not giving
What are we
Wait,
but then you have to
It
doesn't matter.
Hey, ladies, it doesn't matter which one I call x2 minus x1, because 2 minus 1 squared is the same as 1 minus 2 squared.
No, but
But should you
why are you
subtract-
squaring it right now?
Oh,
I knew it, it's illegal.
because I'm squaring it right now. So subtract 20 cosine negative pi over 6t minus pi over 2. So subtract, right, minus 75, all squared. This is all squared, correct?
Yeah.
Square root plus negative 16t squared plus 49 sine pi over 3t minus 20 cosine negative pi over 6t minus pi over 2 minus 20 all squared, correct?
Wait, where does the root end? At the end?
Very end.
Yeah, like that whole thing is like.
Goes all the way there. Okay?
Wait,
How I feel about that.
wait, are you missing a parentheses for your second thing?
Nope.
No, the one right above that.
1, 2, nope.
She added one in the front.
Oh.
The other one.
All
Oh,
sneaky
you
like.
oh.
Okay, so now to find minimum distance,
Wait, so this
You
is like.
do the derivative.
do derivative, but we're not gonna do the derivative here because that's way too nasty, right?
It's like a chain rule or does our calculation?
We're gonna do a derivative on our calculator.
I don't think I can do this anymore.
A function out of it.
Say again?
Didn't you just take a make a function out of it beforehand and then take the derivative?
Oh, like program?
Like
No, like rectangular.
distance between.
Might be an easier way.
Can we do the easy way?
I don't know, this is the way.
Well, what exactly are we calculating?
Yeah.
Okay, what are we
We're
trying
just
to
trying to
find?
find the minimum
But what's
distance.
this?
Like between SpongeBob and
Minus
like the
y1.
closest point on the Ferris wheel to
Yes.
it?
Yes.
In a, like a diagonal line or in a horizontal line?
It doesn't matter, so if you're here, then what's the distance between the two here? If you're here, what's the distance between the two? It doesn't
So it's
matter.
not just
the minimum distance
zero
at a given
Yeah.
time, what the minimum is.
Yeah, any given time. what's
between the
minimum
path of the
distance?
ball and the path of the Ferris wheel?
Yes.
So basically where they intersect.
Yes.
Well, but when the minimum distance is zero is when they intersect.
Okay, so here's the way to do it on your calculator without pulling your hair out about the derivative. Okay? So in here, I'm gonna make a new function, and this one here, to keep track, this x3 is going to be my, this one, distance. So square root of x1, x2 minus x1 squared, right? You can just do x2 minus x1. Just go function, go alpha f4, x2 minus x1 squared
Why is it still giving me?
plus y2 minus y1 squared. That's it. Square root of all that, you're done. Okay? Correct? Oh, actually,
Is it?
Nothing's showing up.
Hold on a second. Fred, no. Delete that because actually, just delete
Oh, I
it.
didn't highlight it, that's why. I was like,
Put T in here, into X3, and then Y cube put that.
Is there a way to like copy and paste?
Aww. Miss Wanda, don't you have to do the derivatives?
Yes, yes, yes,
before
you
it?
do.
Before it?
We are going to do the derivative, but just wait. Oh, shoot.
Oh.
turn this on. Should I keep typing or should we wait? Like highlighted.
I'm gonna wait as well.
Wait,
Yeah.
Yes.
Oh, yeah, but you don't have anything near Y.
That is,
We have to redo it.
we're in the wrong mode.
What? This is what?
So we have to
retype
retype
it.
that Y.
Okay, so
Well,
let's
let's
get
do
off
Y.
of this. Let's get
Wait,
off of this.
We're redoing it.
Let's hold off on that for a second. Yeah.
How much
Are we just
longer
gonna?
on the paper would that have gone?
Not very long, because I was
Okay.
gonna do it all on the
I'm just gonna-
calculator, so we're gonna come back to
Okay,
that.
so I can, this
This much, I have that much, we'll be fine.
Okay, just wanna know like,
Yeah.
how much I have to
It don't even write that small. I don't understand how we can.
What is 10.3?
Okay, so 10.3, this is actually where we really, do the, calculus for the parametrics. Okay, so we're gonna look at slope, arc length, and then surface area here. So if I have this, x equal to 4 cosine t, y equal to 2 sine 2t, let's find dy dx at t equal to pi over 4. So here's my graph. Let's get rid of all this. Well, you know what, let's keep that in because we did. So 4 cosine t, 2 sine 2t. Okay, and we're on 0 to pi over 4, so let's look at 2 pi. 0 to 2 pi. And we know this is,
Are we abandoning
cosine is 4, sine is 2, so we don't need this huge of a window. Right, so x we need to know negative 5 to 5, and y is negative 5 to 5.
Wait, what is the interval for wow.
Okay,
Oh, what's it?
so what's the graph?
Infinity.
Yeah.
Does that mean I have to delete all the other stuff?
No, just go down to X3.
Yeah, and then you can, like.
Oh, turn it off?
Yeah.
Okay,
just
I
unmute.
understand the other side. Wait, what was the mode that we were in?
That's so
We
cute.
were parametric.
Okay, so this one,
Yeah.
so what's possible here is
Oh,
that,
that's a cool.
ladies,
There you go, fine.
what's possible here is we no longer have a function, right? So parametrics, we no longer have functions, but what we can do is we can find slope of the tangent line. We can still talk about slope of the tangent line here. Okay, so slope of the tangent line at t equal to pi over 4. If you go to trace, second trace, do value pi divided by 4. At this point, we can find slope of the tangent line. Okay? If you actually go second calc, it's sitting right here. You can actually do that. dy dx. Right? And then just do add pi divided by 4. Look what the slope is. 0. So you actually have a horizontal tangent line up there. Okay?
What does value do or what
Value gives you what your x and y coordinates are at a particular time. And dy dx gives you the slope of the tangent.
When I put 2ydx, it didn't something.
You have to start typing, Like, it'll just give you a random value wherever you're at.
And then what did we have to press?
Yeah.
Series.
And then just type in value.
But value or do you type it?
And then.
Okay, so we want to find this value by hand.
You just type it like, and then enter, because I just like thought it was.
Okay, so we're gonna use a chain rule. You're gonna miss this if you're talking. So I'm gonna use a chain rule, so dy dt. If I do dy dx, I need to multiply this by, if I want dy dt and I go dy dx first, I need to multiply this by dx dt. Right, this is a chain rule. And again, in your brain, what you're thinking, the dx's cancel out, but you will never ever say that outside this room. Okay? So therefore, dy dx is equal to dy dt divided by dx dt. Okay? So that's what we use, right? So for our parametrics up here, x equal to 4 cosine t, y equal to 2 sine 2t. Right, dx dt, the derivative of x with respect to t is negative 4 sine t. The derivative of y with respect to t, 4 cosine 2t. And so now what we get is dy dx, right? That's just dy dt divided by dx dt. So 4 cosine 2t divided by negative 4 sine t, which reduces to negative cosine 2t divided by sine t, correct? Okay, so now at pi over 4, dy dx is equal to negative cosine 2 times pi over 4 times, or divide by sine pi over 4. But this becomes cosine pi over 2, which is 0. And sine pi over 4 is non-zero. So then this whole thing is 0. Okay? So you can find slope of the tangent line. You can also find concavity. So at this point, is this point concave up or concave down? Concave down, so we should be able to show that.
And that one. Because for the slope, it works.
For slope
at
is
this
here, but
point.
same thing for concavity, so wherever you are on the curve, so even if you were over here, you're actually going to be concave up on this side.
So just imagine it like ending at the top.
Yeah, so just imagine like just a little chunk around it. Not the whole graph, you don't want the whole graph, right? You just want like a little piece of it. Are you concave up in that region, or are you concave down?
So you're not looking at the whole into.
You're not looking at the whole thing. Again, you're not looking at just as, you're not looking at the picture as a whole, you're just looking at a small chunk of it. Okay, so a small chunk of it around here, right? Or a small chunk of it around here. These are all concave down. Concave up would be here, 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 right? Here.
And the end of the.
And yeah, we have
Is it
nothing, right? Badness going on. And we can actually see that. So for concavity, we need second derivative, right? So we can do second derivative on this. So we want derivative with respect to t of dy dx. Right? Again, chain rule on this. If I want the derivative with respect to t, I'm going to do the derivative with respect to x first. So this becomes d squared y dx squared times so if I want the derivative with respect to t, and I do the derivative with respect to x first, what do I need to add in over here? Attendant with this, dt. dx dt. Again, this combined is going to be dt, correct? And so here, this is the derivative with respect to x of dy dx, it's just the second derivative. So x dt, right? So then this is how we get the second derivative. D squared y dx squared is equal to derivative with respect to t of dy dx divided by dx dt. This is our second derivative. Okay?
Is it just ddt of dy dx or the whole thing?
dt of dy dx divided by dx dt. So that's how we get it.
Ms. Melanish, what are you doing in the red?
I'm just doing a chain rule down here in the end.
Oh,
So
just
you
for
can
the
see what this is up here. I'm just doing a chain rule. Okay? All right. So I'm gonna recopy it over here. Because I need to use it, I don't have enough room in there. So d squared y dx squared is just d dt of dy dx over dx dt. All right, so from before dy dx, this was equal to negative cosine 2t over sine t. Is that right? Yeah. Okay, so now d squared y dx squared. Derivative of this with respect to t, I need to use quotient rule. Okay. So quotient rule, bottom to top. Sine t times 2 cosine 2t. Is that right? Minus top, low d high, minus high d low, low d
Isn't it
low.
negative 2 sine? Negative 2 sine. Oh, no, it would be positive.
Low d high, positive 2 sine 2t, right? Minus high d low, so that becomes plus cosine 2t cosine t. Square the bottom, there you go. So sine squared t divided by dx dt. What was dx dt? Negative 4 sine t.
I'm still confused how you got to finding exactly what the second derivative was. Like the equation to get to the second.
How do we get here?
Yeah.
Let me finish.
Thank you.
Whatever, right, is equal to ddx of whatever times, right? So this is what I want to go for. So here, if I do derivative with respect to x, then,
Shouldn't be dy dt.
Because, no, hold on. If I just want to split this one up, okay? Think of it as fractions. You're not supposed to, but it's okay in here. ddx times dx dt, right? So we can all think in fractions. That works, correct? Okay, so whatever I do here, I'm just going to split it up in these two pieces, right?
So why are we?
Oh, are we okay with this? Just splitting it up. Doesn't matter where this, what's in here.
Why are we?
Are you okay with this?
Yeah.
Yeah, okay, we good?
Okay.
Is that given?
Okay. Okay, Fiona, help me out here.
I have no idea what's going on.
Okay, but in terms of fractions, do you see the fractions? If I take this as fractions, do you see this? This is equal to this.
Yeah.
Right? Okay.
Oh yeah, Because the DX's cancel out, right? But
Yes.
how would you just like decide to do that? Like if we didn't know it before?
I'm just showing you this, right? You would have asked it, I don't know necessarily you would have come up with this on your own.
Why is it in terms of DDT?
Okay, so
Derivative.
here,
T of
hold on,
your first
Jamila?
Why are we splitting it?
Because here is why we're splitting it up. So now what we have is dy dx. That's what we have. Okay? That's what we have. So now I want the derivative with respect to t of dy dx.
D2y dx.
No, this isn't.
No, for.
This is just this. Okay? Now here I have the derivative, but I want to do the derivative again with respect to x. I have the first derivative with respect to x, and I want to do it again with respect to x. So this is the second derivative.
So then that would be D squared, right?
This one would be d squared y dx squared
Oh, yeah.
Yeah.
times dx dt.
Yeah.
Oh, because.
And then you just multiply to the other side.
Yeah, so this is the, I have dy dx already here, right? I already have the derivative, and now I want the derivative again with respect to x, so that is just the second derivative.
Can we go back? I think Julia may have been asking this. When you go back to the original chain rule for the first derivative, why is it dy dt?
Yeah, I think
Yeah.
that was supposed to be.
Yeah, this one's different. Again, I'm not sure, I don't know if I'd expect you to come up with this on your own.
But why? How come for this one it's dy dt instead of ddt?
Well, you could do the same thing. I can do exactly the same thing. You wanna see, I can do exactly the same thing.
I can overlook.
ddt is the same as ddx, right? dx dt. So this, right?
Yeah. Alright, is our,
Right, it's the same thing. Same thing as up here, correct?
yeah.
Now, it's what I put into it is different. Here, I'm just gonna put in y.
That just first derivative.
So here, this is just dy dt equal to dy dx times dx dt.
But
Alright, it's the same thing as this one, but now I'm just putting two different things into it. Okay?
And how do you know what to put?
If you look at
Back
this
is
and
because
you
you
cancel each other, everything, you would cancel everything out. It would be like 1 to 1, but for the other one, it doesn't work the same way.
Which one?
For the secondary derivative, because you have one dy still like,
Where? It works the same.
but if you try to cancel this out,
No, I'm canceling it out here. The blue part's canceling out here,
yeah.
right? It still works, correct?
but how you can just say that it's instead of dy dx, why would you just say it's y?
Because that's worse.
Because dy dx is the first derivative. You want to take the derivative of the first, so, right, and the first y is just like your original equation.
And you're taking the derivative.
And d dt of y is your first derivative. And then we already have dx, so you get to the, or dy dx, that's your first derivative. So when you want to find your second derivative, you have to take the derivative of the
Which
first
we can't
derivative.
do.
So that's what's going on there.
See if we can get somewhere we can do.
Yeah, this, I've already done the first derivative on this one.
So you have y there. You want
Oh,
y. Get the first derivative, and you want the second derivative, so you plug in the first derivative.
Let's just say.
Let's just say memorize it and move on.
We're rather than this, Mom, let me get this, which one?
Yeah, because everything
Okay, but we can't do this. We have to get the changes
Yes,
we have.
ma'am.
and this instead.
Like what parts of
Well, no,
10.1
this is what we
and
want.
2 are
We
gonna
want
be
this.
replaced?
Wait, and it's 10.3,
So this
no.
is that.
Did I write it in there?
Yeah.
But I thought this was the only one we're
On the website, it just
So
says
like, I just don't get why we're looking with
Can we just
like.
not-
Let's just pretend what I
We're-
did.
Okay,
Thank you.
I don't know what
Wait,
you're
so
doing.
for times 2, is it 10? including what we did.
It's just,
Yeah.
yeah.
Actually, arc length, this one here, it's not, this one actually isn't bad, 10.2 isn't bad, it's just applying stuff. Alright, so arc length, you know, arc length,
Yeah.
arc length is square root of,
I went to the next page.
1 plus,
Sorry. Wait, I'm not ready. Oh, F prime of X.
f prime, so dy dx squared dx, correct? From A to B, correct? Okay, so now for parametrics, dy dx, we actually know what that is. Dy dx is dy dt over dx dt all squared, correct? But now we are in t. You can't just change it to t, you actually have to do a chain rule on this to t. Okay, so I want to do a chain rule. How do I actually change this to get dt out of it? I want to end up with dt. Use your fraction powers. What do I multiply this by?
dt over dx.
Oh, wait a minute.
The X over dt.
Or dx.
Oh crap, this isn't gonna make sense. Oh, yeah, it does, yeah, it does, yeah, it does. So what do you, yeah, dx dt, correct?
Yeah.
Okay, so you use that in your brain, the dt's cancel out, right?
Yeah.
Okay, so now, A to B,
But are you
I feel so sorry for you.
huh? Yeah, but hold on, I'm still left with dx, but this one here, this here I need to integrate with respect to x, correct? Now I'm in t, I need this to integrate with respect to t.
Doesn't it cancel so that it
Just whatever.
It's not gonna cancel, hold on, I gotta deal with this. I'm gonna deal with this in a second. Oh my goodness, girl, it's just like your brain's exploded.
I'm tired, my brain hurts.
Okay.
So if we already had the X dt within the square root, can we just leave it this way or not?
You can't leave it this way, but let me tell you, there's a shorter, easier, quicker way.
Yeah, we don't want to cancel.
Shall I work on it, or should we just leave it here and you gotta memorize this?
No.
This is easy to remember.
Oh, yeah.
Actually, that's true. It's not that hard.
You
to
just-
remember.
Yeah, how about we go through it and see which one we prefer to remember? I agree.
Making it, keeping the.
Alright, let's do this. So, this is squared, correct? Down here, this, and it's all squared, it doesn't mean the second derivative, it just means that that's squared.
So that means one
So here, I can rewrite this as, and don't make your heads explode, I mean, I'm gonna make your head explode, but don't let it explode too much just yet. Isn't this the same as dx dt squared plus dy dt squared all over dx dt squared? I did the squared here. I did the squared here, hold on, let me explain. I did the squared here, I did the squared here, and I got lowest common denominator.
Yeah.
That's what I did.
That sounds like.
So I squared here, lowest common denominator. Got it? Okay, so now, this is all underneath the square root, correct? So I can square root the top, and when I square root the bottom, I come up with dx dt.
And that cancels
And
out.
that cancels with that.
Wait, no, repeat that again.
So I have square root, I'll square root the top,
Oh, okay.
and I square root the denominator. When I square root the denominator, I end up with dx dt, and that cancels with this dx dt. So this cancels. So I'm left with integral from A to B, square root of dx dt squared plus dy dt squared dt. So this one, the surface area is actually, I mean, arc length is a little bit easier, I think.
Just a question, isn't this as if you would take y and then the derivative of y would be 1 and So you can put 1, 2.
Wait, I'm taking the derivative, yeah, but remember, we're in parametrics,
Yeah.
right?
No, yeah, that's what because it says if you take the like the origin which is the origin formula is 1 plus f prime x
Yeah.
prime. So could you think of it as if you would say that the 1 is whatever y was?
No, one is not whole bracket, yeah.
No, so
Yeah, and this one actually might be easier to deal with because here, back here we have dy dx is this. You want to square it and manage it, or do you want to just square this one and this one and manage it? I think I'd rather just square these two here and deal with that algebra rather than doing 1 plus this squared and then doing algebra.
it's something else and it makes sense in my head, but I don't know how to explain.
Oh, okay. All right, listen.
And then also, since we originally were to integrate with respect to x, then we could change the a and the b.
You have to change, put those in terms of, so we have to solve for it.
Yeah, that's a little fuzzy. We'll just make sure that's true. You are right, Melissa, we do have to change it so that we can call this, I don't know, A star, B star. And really what it comes out to be is, instead of x equals, we want t equals. You're right. Okay?
So is this the equation for finding R thing for all parametrics?
All parametrics. All parametrics.
So is cool stuff.
Okay?
No, it's not.
Can we get a
Just
brain
because
break?
it's
Just
just-
Just the 2 sections.
Can we get a brain break?
Classes over in 5 minutes, Ruby.
This one on it?
Yep.
When do we start AP review?
I don't know, whenever we finish this. We've got to finish chapter 10, 11, 12.
Wait, so is that like mid-March or beginning of
It's
March?
60 end of March.
End of March. Wait, are we done? No.
Yeah, what we did today
How
was
long
like.
did it take us to do it?
But she didn't do that worksheet, so you need to.
Yeah, that's a good question.
This one's easy, it's quick, it's simple. Parametric smooth. Is this parametric smooth?
Yeah.
The answer is yes. You don't see a corner point, right? So parametric is considered smooth if two things happen.
Why do we need to know this?
Because
Smooth is such a mathematical.
so here, if
Kind of
dx dt and dy dt are not both simultaneously zero. Okay? So what this means is dy dx, right, which is dy dt over dx dt, right? What we don't want is this one to be zero when this one is zero. Because what happens if they are both simultaneously zero?
Get it flat.
Indeterminate. You may not use L'Hopital on a derivative. And even though you have a derivative.
Wait, when did
I
you use
cannot
L'Hopital on a
L'Hopital.
limit, right? Yeah.
Okay. So, and here's an interesting thing.
Wait, I don't know what.
If dy dt is zero, if this is zero, what kind of a line do you have, vertical or horizontal?
Horizontal.
Yeah, horizontal. You have a horizontal tangent, and if dx dt is zero, then you have a vertical tangent, right? So then this one over here, at t equal to 0, right? This one here would be a vertical tangent. So that means dx dt would be 0.
So it would be 0, but they can't both be 0 at the same time.
Cannot be both be 0 at the same time, because what that means is you're getting something like this, which is not smoothing.
So wait, can you repeat,
So what are the
at
two-
that point, at pi over 4 in that graph, in that infinity thing?
So at pi over 4, dx, dy dt is 0.
Because it's a horizontal.
Yeah. dy dt is 0 because you have horizontal. So over here, dx dt would be 0.
Wait, so what are the two conditions? So what was the first?
So this has to happen. They're not both simultaneously 0.
And that's the only condition?
That is the only condition. And it kind of makes sense. Okay, so smoothness.
I like a right angle.
All right, we still have surface area to
It's
do.
anything but like less than right angle.
Goodbye.
Half this video is just lying.